Hello there, welcome back. Today I'm going to carry on with the thing I was working on last week, which is trying to turn UUIDs into a different ID format deterministically. So given some input UUID, I will always generate the same output ID in this different format. And tonight I'm going to be looking at unfold. I started looking at it last week but didn't get it working, so I'll look at that. And in particular, just trying to take some input, so a list of bytes or a list of word64s, whatever it is, and turn that into a list of 6-bit values, I guess. The reason I'm doing this is I have this, this is the UID, right? This is the input value. It's a 128-bit value, so it's 8 bytes long. Is that right? No, 16 bytes long, sorry. 16 8-bit words long. And ultimately, I want to turn it into an 18 alphanumeric string. Now, last week I did quickly the 15 character alphanumeric ID. And that's relatively easy, right? You just take the first 15 bytes out of your UID. So these are two 4-bit values. If you take two of them together, it gives you the byte. Just take those, take the first 15 of those, and just call modulo 61 on them, and that gives you value between 0 and 61, obviously. And then look up in a predefined list of alphanumeric characters. And given the same input, that will always produce the same output, and it's reasonably random. So UID v4 is pretty random. This number 4 is actually fixed, but little detail. But it's reasonably random. You get a pretty good distribution in your generated ID, and it's deterministic. So given the same input, you always produce the same ID. And we're doing this for duplicate detection. So that's sufficiently good for that. However, the ID format I'm really trying to put it into is 18 alphanumeric characters. Now you could do the same thing, but you're only going to get 16 characters worth of data. And we want to use the full 18. Right? You get a lot more space if you use the 18 alphanumeric characters. And we want to distribute as randomly as possible, reduce the amount of collisions as much as possible. So I want to take this 16 byte, 16 word 8 value, and generate 18 alphanumeric characters from it. And the way to do that, the way I'm going to do it, is instead of just taking a byte and calling modulo 61 in it, I'm going to take a 6-bit value. So I'll take the first 6 bits, call modulo 61 in it. That'll give me the index to look at my list of characters. And then I'm going to take the next 6 bits. Now this is annoying because it goes between words, and look that up. And I'll take the next 6 bits, and again that's some from byte 2 and some from byte 3, and look it up, and so on until we have the 18 alphanumeric characters that we want. Okay, so we have a couple of options for the input. We can take our UID and split it up into a couple of word64s, which is what I was doing last time. Or I can also turn it into a list of word 8s. I think the word64s will be slightly easier, so I'm going to stick with that. But what I was trying to do is called to chunks, and to chunks is defined in terms of an unfold, and it's saying run this function, over, what's this? Okay, so it's creating one of these things. So create this as your initial value, and it's going to run it over the input, which is a UID. Okay, so I take the UID, I turn it to two 64-bit words, I pack it into this record. So it's got the words, stop hovering. It's got the words, the two 64-bit values. I had a function which will get me out of the first or second word, and then I'm keeping track of where I am within that word. But when I was running it last time, it didn't work. So what I want to do before I come with this, because again, a little bit complicated, is just take a little side detour into unfoldr and see if I can make sure I understand how that works, and then just maybe build up a little bit of bit by bit, trying to get the bits out. And for that, I'm going to create a new file, and I'm going to call it unfold. I'm going to call it unfoldy in case the name clashes. The module unfoldy, and I'm going to say chunks or whatever. I think chunks is a good enough name. Okay, so in here, what I want is, just wondering why I'm not getting any errors and warnings. Is it actually working? It's not what I expected. Hang on a second. I would expect HLS to kick in. Oh, I haven't told Cabal about it. Okay, is it other modules or something? I can't remember what the keyword is. And it's unfoldy. Is that going to be happier? Okay. There we go. Cool, that's what I expected. Okay, so chunks. Let's say we take a pair of word 64s. So that's what I'm going to get out of the UUID. And I'm going to turn this into a list of, let's say word 8. It's probably good enough. It just needs to be some kind of, some value between 0 and 61 is what I want to end up with. So just import that and import this. And that's undefined for now. Okay. So for now, I'm going to ignore the second word. I'm going to unfold the first word first and see if I can get that working, and then I'll look at doing it across the two words. So I want to say unfoldr, which I will import from data list. So unfoldr, and this is going to take a function which goes from some initial value to maybe some output value and the next value to pass in. Then we take an initial value and then it returns the list of things. Okay, so we want to say chunk, and we're going to give it, let's initially give it a pair. So we're going to give it the first word, so the thing that we are working through, and some offset within that. Okay, so chunk is now going to go from a word 64 and an int, so the int is me keeping track of where we are in this word, and we're going to return a single word 8. Okay. Oh, sorry. We're going to return maybe a word 8 and the next input. So, thinking about stopping here, we're going to stop when the offset plus the 6 bits we're trying to get is outside of this word 64. When we've fallen off the end. So I can say something like chunk W, thing we're looking at, and the offset. Wow. I just put a garden here. So I want to say if offset offset plus 6, I think it's going to be, is greater than 64. I mean, it's an int 64, so we can just say if we exceed the 64. In that case, I'm going to do something. In fact, I know what I'm going to do. I'm going to return nothing. So I'm going to say we cannot extract any more 6-bit values. In fact, we'll always try. So I'm going to say if we got to the point where we are 64 bits or more into it, we'll return nothing. Otherwise, we'll do what we can. So if there are less than 6 bits left, we'll just treat it as a 6-bit value, but there'll be some leading zeros. So otherwise, what do we want to do? Well, first we want to take our word and shift it by the offset. So what are we doing? Saying W, and we want to shift R by offset. Can I import that? Data bits, shift R, so I wanted. And shift R, anything that implements binary, so any of these bits, I think Word 64 does. Okay. So that's the first thing. What's the error about? Sorry. Couldn't match type int with Word 64 int. I'll come back in a second. And take my W, I'm going to shift it by the offset amount, and that's going to give me a new Word 64, but shifted 6 bits. It initially shifted 0 bits. And then you'll just take that and mask it with 61. That fits. Okay. So expect type, blah, blah. Okay, this is the first thing. So this gives me the new value. So this is my result. And then the next thing I'm going to pass in is the new offset. It's going to be offset plus 6. Okay, now, a couple of things. It's going to be just that. Okay, and now we have a Word 64. We want it to be a Word 8, so I'm hoping I can just say from integral, but yeah, it looks like I can. We're just forcing it to convert it into a Word 8. It's going to be a bit lossy, but that's okay because we only want the first 61th value. Not 61 at all, we want to mask it, but it's really 63. So 63 will give us the full 6 bits. Okay, so now this error. Yeah, okay. So the second value we produce it. So the first value, I think it's a result. Let me just check that. No, in unfoldr. Yeah, so we return result, which is our Word 8, and then the second thing needs to be this pair of a Word 64 and an int. So this is our Word 8. Then we return the same word and the offset. Okay. This is a little bit dense. I think there's too much happening on this line. But anyway, the principle is that if you call chunks on some word 64, it should give you the 6-bit values. Okay, see if that's true. So first of all, it imports full unfoldr. Should call it chunky. And I also want to import text.printf, I think. Okay, and if I say a is equal to some, doesn't really matter what the number is, some number of type word 64. Okay, and then I should say printf and give it a format of 0, I guess 64b. And then A, do something with a new line at the end of it. Okay, so this is the thing we're going to be shifting. So the first 6 bits, I expect to be that, and then the next 6 bits will be that. Is that right? 2, 4, 5, 6, and so on. Okay, so if I then say chunks, I think that just takes A, but let me just take the head of that. Okay. Let me do A and 0 because I haven't done the second word 64 yet. I know it's partial. Uncoms. List of uncoms. Can I say take 1? Yeah, that's also partial. I don't understand why I didn't think that was. Right. We print that out, and then we'll take 1 from here, and we will map over that. So we map over that, given some value x. I'm going to say printf %. I'm going to print them as 8 characters, or 8 bits, and the reason for that is I want to make sure that the first 2 bits are empty, because I guess there's a danger that I could chunk it into something bigger than 6 bits and not notice. I'm going to map that over taking 1. Good. Which thing does it not know about? Use a print. That's not going to make a difference, the same thing. So can I say X is of type word 8? It says type word, but it's not. Data dot data word. Oops. So now I can say word 8. I can, but it still gives me the same error. Okay, what does it think it is? What's the type of this? It's a list of word 8s, so that shouldn't be the problem with printing. Oh, hang on a second. That's my value for A. Printf % 060, oh no, 08b, and it was the value 39 of type word 8. Okay, but it's the right answer. I just don't know why my printing didn't work. Okay, if I now get rid of this, it gives me a list, and it's, I guess it's the other way around, so it's taken, this is my first value, this is my second value. It doesn't matter which way around it is because I just need to be predictable. Yeah, that's value 6, I think. Is it the value 6? That's not the value 6, that's the value 3. That's the value 6. So it looks like it might have missed slightly. 1, 2, 3, 4, 5, 6. Oh, no, that's correct. Sorry, those leading zeros are misleading. I was just checking that they were present, I guess. Okay, so given these chunks, oops, so chunks should still be word 64 to word 64 to word 8, list of word 8s. I take the chunks. I don't know why I can't just map printf over those. Maybe something special about printf. So I can say pp is, what's the type of printf? This is going to be a funny type. Yeah, that's really not the type I expected. So given R is something I don't understand, and printf type, and some string, do the printing of it. How does that work? I just wonder if I can write a function and explicitly tell what the types are and then see if that works. So if we say ppx is printf of %08b, and this whole thing is of type word 8 to R, but I'll need the constraint on this. So can I say printf type R? Oh yes, almost. Maybe, I don't know. It errored before I got to that part. I could not deduce that. Okay. Can I say word 8 to string? Oops. Yeah. So I say pp34. Oh, I think I might give the type of X as being that. All is just to print out the binary bits. I can't redefine pp, but I can maybe do pp prime. Nope, not like that, apparently. Can I give the type here? So we can say pp type word 8 string equal to this. No. Okay, then you say print chunks. I'm going to take a list of word 8 and it's going to run under IO say print chunks is equal to map printf %08b. Oh, it's not map, it's map m underscore. Print it, or I'll import it. We might be okay there. And I'll export that as well. Hoping now I've given enough type information to the compiler so that it knows how to print that thing out. Right. A equals that. And then it was chunks of A and 0, because I haven't done the second word yet. And then print chunks of chunks A and 0. Almost. Reload. Right. A is that. I'll print A. Where's my printf of A? Somewhere here. Okay, so that's the input. And this is what we're splitting into. This matches this, which is correct. And then we get, I've missed one by one. Then we get this, yep, which matches here. And then we get something like that. That looks about right. Okay, so it does look like we're turning into 6-bit chunks, which is cool. Okay, so now we need to switch words at some point. So I need to say annoyingly, we need to give it 2 words now. To put words in there and words in here, and this is now a pair of word 64s and an int, and it's going to return maybe a word 8 or a pair of word 64s. Or a pair of word 64s and an int. Okay, so now we're going to stop not at 64 but 128. And I'm going to match these. I'm going to just deconstruct them as W1 and W2. And we'll say if we're in the first word, so we can actually, I'll do the first word first. So I can say if the offset is less than 64, then I'm just going to call this, I'm going to create a helper called 6-bits. And I think I might just say just 6-bits. So I'll drop the maybe here because we don't need that. And it's going to go from a word 64 to that. So just 6 bits of W1, and this whole is this bit. So W, oh, we need to give it the offset as well. Oh, that's annoying. I was hoping it would simplify it, but I'm not sure it does, because you need to return. In fact, let me just go from word 64 and an offset, we will return a word 8. So it's just the first bit of this. Okay, and I'm going to call this whole thing W's. So 6-bit and offset. And that's the first part we're going to return, so that's the answer we're going to return, and then we're also going to return a tuple containing the words and offset plus 6. And then otherwise we'll do the same thing but with W2. Right. And then hopefully I can say something like UUID, which is going to go, I can run their IO because I need to chunk the UUID. I need to generate the UUID, sorry, and that I think needs access to secure random or some kind of random generator. We won't take any input, we'll run their IO to generate the UUID, and it will return. We might as well just print them, to be honest. We won't return anything, so chunk UUID. First thing to do is v4.generate or something. v4.new. I can't remember what it was. I have it in main. Somewhere, do I? I do not. I was getting it. Okay, I was getting the input from the command line. UUID.v4, but it's probably data. Okay, so now I can say v4.new create, generate, random. Let's go and look. UUID, module UUID. Give me a second. Next random. Okay, so I should have a random number at this point. Next random, let's type of this. Yeah, it's UUID, that's what I wanted. Okay, so I have my UUID, and then it's UUID, one second, import data UUID qualified as UUID. So now I can say UUID dot to word 64. Find qualified in post position. What is it? Is that not fine? Import UUID v4 is redundant. Why is it redundant? Confused now. Can I put the qualified there if I have empty brackets? No, I don't want those brackets at all. It's the whole point of doing it qualified. Hang on a second, let me export chunky UID, so I'll shut that warning up. Prevalent scope v4.nextRandom. Next random is in UUID data UID v4. Import that. Oh, I didn't qualify it, that's why. Okay. Right. So I now have this should be a pair of word 64s, which we know we can chunk. So we can say print chunks of chunks of this thing. Right. That's what I'm hoping we can do. Okay, so I should be able to call chunky UID. It should generate one. Oh, let me print it out as well. Put strlen the put strlen show UID, and we'll print out the chunks. The other thing I will do before I print the chunks actually is printf present 064b of UID with a new line. Okay, I can't do that. Let me instead say let words equal this. So we'll get 2 words back. I'm going to print out we know it's 2 things, so we can print out the first words, and then we can print out the second, and then we'll chunk it. Oh, yeah, I'll print out enough so I can see what's going on. Oops. Come on. This thing. So import unfoldr, and then we will say something. No, what do I call it? Chunky UID. Right, good. What's it showing me? So we generated this UID, and we got these 2 words. And this one, I might change it so we print out 6 bits at a time. Rather than 8 bits. And I might also get rid of a new line. I'm just put a couple of spaces between them. So this is going to be a very long line. Okay, so these are our 2 input words that come from this UUID. And the first bit is this last 6 bits in the first word. Then you get these 6 bits and so on. And then these things look wrong. Ah, okay, yes, when I fall off the end of this, I just keep returning zeros because I'm now shifting it by 64 plus this. So what I really want to do is, if we're in the second word, we're going to shift it by offset minus 64. Because we want to know where we are in that word, not where we are overall. Okay, try it again. Okay, so the second, I guess we work backwards, do we? It's not looking right. That does not match the end of this. So 1, 2, 3, 4, 5, 6. What's 64 divided by 6? Day of 6 is 10 and 4 bits left over. So we will mess up at the end a little bit. So I did want to care about those trailing bits and just ignore them. So now I'm going to say actually it is if offset plus 6 is less than 64. So we won't try and eat the last bits. I'm going to print this in 2 halves. So this is going to take a list of word 8s, and we're going to go to a pair of word 8s, pair of list of word 8s. So what I'm thinking is we take our big list, we split it into two halves, we print the first half, new line, second half, new line. That's what we'll do. So half of some x's is take or split at. What is it? It's like a split at. And we want to split at the length of x's divided by 2 x's. Okay. So now we can say like W1. Let's say let W1 W2 equal half the x's. Then we'll print out W1. Then we'll print out an empty line. Then we will print out 06B space of W2. We'll print out another blank line. And hopefully we should have something that's a little bit more readable. Interesting. Okay, it looks like there's 0, 1, but basically it looked like we're going to be 4 bits off. So those will get dropped, and the last thing returned should be this, which is correct. That's what we're getting back. Okay, so when we go into the second word, I've obviously messed up a bit. So we should call it at 60 and say, oh nasty, okay, we call it at 60. This does not match because we say there's only 4 bits left. So then we go on to the next word, and our offset is 60, and we subtract 64 from it, we get -4. and then we try and shift right by -4 bits. I think that's probably the thing that's failing. Right, so we want to be a little bit smarter about how we do this. I guess like in an ideal world, we would take those 4 bits and join them onto this. But I think this is where this chunking gets a bit more complicated, because you then need to keep track of where we are in the current word and where we are in total across the whole 128 bits. So I think this is where I was building my record before. So let's say chunk is equal to chunk, and it's a record, and it's going to have words, which are a pair of word 64s, and it's going to have an offset, which is an int, so that's how far through we are in a single word, and then the current word, which is going to be another int. Is that right? But what I really want to do is have this as being first or second. So I'm going to say word 64, word 64, and it's going to go to one of those things. And in fact, it is a word 64 for me, but really the type of this is A to A to A. For all A. Oh, but it doesn't know how to put it there. Okay. But that's the idea. I'll put it back to word 64 so the compiler doesn't get upset. Okay, so now when we chunk it, we actually want to go from a chunk to maybe this and a chunk. I think I called it chunker before, which is a slightly better name. Right, can I just rename this? I can, cool. Good, it's just renamed everything inside here, which is really not what I want to do. So this is words, this, whoops, this was offset, and this was the current word that we're in. Okay, and we're going to call it with chunker of words 0 and first. Okay, so now we can say, given the chunker of words, offset, and some function, one, oops, too many brackets. Given one, what? Okay. Oh, I can't call it that. Just call it O. Right, so if our offset is outside 128 bits and we do nothing, that seems sensible. If it is within the first word, No, it's within the current word. Let's say that. Then we will take the current word, which is fn of w's. We will apply the offset to it, and then we will return a new chunker, passing in the words, the new offset, and the current function. And offset to O. Okay. Otherwise, if offset is greater than 64, offset plus 6 is greater than 64, then we want to, I'm just going to call chunk again, but this time I'm going to call it with chunker words 0 and second. Right, the trouble is I'll just keep, well, now the offset's never going to get to 168. Okay, not what I wanted. It's back to where it was. So get rid of the record and put things back. I just get rid of this now, I think. Okay, back to where we were. So now we have this problem where if the offset plus 6 is greater than 64 and the offset is less than 64, that is if we're in this kind of window, so the offset itself hasn't yet got to second word, but we're trying to grab more bits than are available. I think at this point I want to say just chunk again, but I'm just going to move the offset slightly. And it's going to be the words, how does this work? It's going to be the words and the new offset, which is going to be 64. Not convinced it's going to work. Let's give it a go though. It's done something. Okay, so these are the first 6, and they should appear here. That's good. Then we're going to skip the last 4. So then the next 6 should be something like that, which looks right. That's where our first word ends. Second word looks like that. That's good. And then it's got this thing which looks like that. That's good. At the very end, we should skip 4. Except we don't. We actually just consume it. Okay, so we consume this as our last full thing. Then we take these 4 and we just shift them 6 anyway. Or we shift them, whatever it is in this case, it's 60 something. And then we take those. And that seems okay. That gives me some values back. Okay, so I now have something which does the chunking for me. So go back to main. We've got 5 minutes. Right, to chunks. So this goes UUID to word 60, list of word 64s, and this goes pair word 64s to a list of word 8s. Okay, I'm going to get rid of all my printing debug stuff. Mostly because I want to steal that name chunky UUID again. So chunk UUID, I want to go from a UUID to a list of word 8s. So chunk UUID, wonderful. Given some UUID is going to be chunks of UUID dot word 64 fact. I can just do that, I think. UUID. Okay, because I want to refer to it as a type. I'm just going to import it again like that. And now it's gone confused. Oh, our names clash here. So does that be UUID dot that? We take that out. Does that work? Doesn't look like it. Wait a second. This. Oh, it says from. Oh, hang on, that's why. Right. So now I can get rid of this. I can add to reduce this, I think. Yep. Okay, so I'm exporting chunky UUID. So here, I should be able to say chunky UUID, then import that. Then I should be able to get rid of chunks. And get rid of all these things we're not using. So in theory, if I go back to here, I can say UUID gen pipes we could run. Okay, I had something in here which says take 2 because it was running forever previously, so that was just some debugging stuff I left in place. But really I should be able to do this now. That should give me back the full thing. Where have we got convert input? So convert is just returning a string, but what I really want to do, I think, is say I want to show the UUID or show S. And then show that I'm converting it. I don't want to show it, it's already a string. But the idea is I should be able to grab this. The reason I wanted to show it is so I can grab it and run it again. Say cabal run, paste that in, and I get the same string come back out again. Okay, and this is 18 characters long, and it looks like some kind of reasonable distribution, I don't know. If you do it again, it seems to be making use of letters and numbers. That's really what I'm looking for, in uppercase and lowercase. And then it is deterministic, because if I run it and drop that in again, I get the same output. Cool, okay. So that is taking some string, parsing the UUID, turning it into it's turned to word 8s, but each of those word 8s is representing the value from 6-bit chunks of that UUID. We're skipping 4 characters, or 4 bits, sorry, at the end of the first word, but I think that's okay for this exercise, because the UUID itself is 128 bits long, and the 1862-bit characters, actually we're doing the whole length here. If we took 18 from this, so the 18 alphanumeric characters is roughly equivalent to 107 bits. So we have extra bits we just have extra entropy in the UUID that we don't need to use when we're converting it. We can still use the 18-bit value, the 18 character ID. We can distribute across it pretty well. Did I actually say that? You can distribute across it pretty well, and also not worry about skipping these 4 bits. Yeah, so you can see those 3 won't fit in, but we still take the first 18 and it's all good. Okay, cool. So that is a little diversion into bit shifting and masking and unfolding and converting UIDs into alphanumeric characters. I'm going to leave it there. Not sure what I'll do next week, but probably something different. But I found that quite a fun little diversion. And now I know a lot more about how to do things like shifting and masking in Haskell, and a little bit more about unfolding as well. So yeah, thanks for watching along, and hopefully see you next week for some other bit of Haskell. See you then. Goodbye.